All right, so in this video, we're going to go over our Module 2, Lesson 3, which is our key features of functions notes. So let's start off. So our intercepts of a function. These are points where a function crosses the x-axis or the y-axis. So an x-intercept is also referred to as the zeros of a function. Okay, so you'll hear x-intercept and zeros used interchangeably throughout all of algebra. So it's something to get used to now. So this is the x-coordinate or coordinates of a point where a graph crosses the x-axis. Now the y-intercept is the y-coordinate of a point where a graph crosses the y-axis. So if we're looking at this graph here, we have a nice function. It's a little wavy. You don't have to know what kind of function it is, but we have y-intercepts and x-intercepts of this function. So first, let's identify our y-intercept. And just note that there's only ever going to be one y-intercept, because if there's two y-intercepts, then you don't have a function. What you would have, remember, is a relation. So looking at our y-intercept, this here is our y-axis. Where does this graphed line cross the y-axis? Right here at this point. And we can label that point as 0, because anything on the y-axis will have an x value of 0, and then a y value of -1, -2, and we'll say this is a -2.5. Okay, now if we are looking at our x-intercepts, now we're going to look at the x-axis, which is our vertical axis, our horizontal axis. The x-axis is our horizontal axis, it goes from left to right. Now we have three intercepts because this wavy line intersects the x-axis in three different spots. So first, let's label this point. So here on my x-axis, the y is always going to be equal to 0. So I'm going to start here and count on my x-axis. So I go -1, -2, -3. So the value of this point is going to be -3, 0. Now let's find the value of this point. Well, here, if I start at 0 and go up 1, then that's going to be 1, 0. And then finally, we have this point where it crosses the x-axis. And if I start at 0, we go 1, 2, 3, 4. So that point is 4, 0. Now you should notice something, that our y-intercept, when we have our y-intercept, our x is equal to 0. And when we have our x-intercepts, our y is equal to 0. This will always be true. Our y-intercept will always have x equal to 0, and our x-intercept is always when y is equal to 0. So if I'm looking over here at this table now, how can I identify my x and y-intercept? Well, I need to look for the zeros. So here, my y-intercept is when my x is equal to 0. So these are my x values. And right here is when my x is equal to 0. So that means my y value, f of x, or y value, is equal to -3. Now to find my x-intercept, I'm looking for when my y is 0. Remember, f of x is just a fancy way of writing y. So my y value is 0. So my point where it crosses the x-axis is at 6, 0. All right, so those are your x and y intercepts. Now I want you to pause the video and practice it real quick. Identify your x and y intercepts for 1, 2, and 3. All right, now that you've tried that on your own, we're going to go ahead and take a look at the x-intercepts of this graph here. So we have a nice pretty parabola, which is a quadratic function that we haven't quite learned about yet, but you will in the future. And it crosses the x-axis at 2 points. Okay, so what is the value of this point? Well, again, my y value is always going to be 0, so let's count our x. So -1, -2. So we have the point -2, 0, and this is 1, 2, 3, 4, 0. Okay, all we're doing, unless they label them, we're going to assume that our vertices are at 1, intervals of 1. Now we have our y-intercept. So where does this parabola cross our y-axis? Right here. And what is the value of that point? Well, 1, 2, 3, 4, 5, 6, 7, 8. It's 8 below the x-axis, so it's going to be 0, -8. Now let's look at the table for f of x. We need to identify our x-intercept for f of x, which is at -1, 0. And our y-intercept of f of x is 0, -2. Again, our x-intercept is when y is equal to 0. Our y-intercept is when x is equal to 0. So looking at g of x now, we have our x-intercept. So when y is equal to 0, so 9, 0. And our y-intercept when x is equal to 0, so 0, -12. Now, in this last part, it asks us to compare the functions. So we're looking at tables for f of x and g of x. The x-intercept of blank is greater than the x-intercept of blank. So we're comparing f of x and g of x. So which is greater? 9, because that's the x-intercept of our g of x, or -1, the x-intercept of our f of x. Well, clearly 9 is greater than -1, so that would be our g of x function. So the x-intercept of g of x is greater than the x-intercept of f of x. Now looking at our y-intercepts, our y-intercept here is -2, and our y-intercept here is -12. So which is greater, -12 or -2? Well, -2 is greater than -12. It has a greater value. So that's our f of x function. So the y-intercept of f of x is greater than the y-intercept of g of x. So that's how we can compare two functions. Okay, sometimes they'll give you a graph and a table, sometimes they'll give you two tables. You just never know. All right, so let's move on to intervals of increase and decrease. And it's pretty much as simple as it sounds. Because when I asked you what increasing was, you told me that when you increase, you go up. So when the graph increases from left to right, it is going up from left to right. Okay, so I always like to imagine there's a little stick figure guy standing on this hill. Okay, so I'll try to draw a stick figure guy real quick. And he's going from left to right. He always walks from left to right. So if he's going from left to right, he is going uphill. Well, that's when the function is increasing or going up. So when is the interval or when is the graph decreasing? Well, that's obviously then when it's going down. So if I draw my little stick figure guy and he's going from left to right, you can easily identify that he is going downhill now. So that's when the function is decreasing. The trick comes in is how do I label that or how do I answer that? Well, we already identified that that's when the function is increasing. So what we need to compare it to is where it changes. And it changes right here along this line. So what is the value of x on that line? Well, that's when x is equal to -2. So this function is increasing when x is less than -2. Then it hits its peak or its vertex, and then the function starts to decrease when x is greater than -2. So that's how we would write our answer, or it's one way that we could write our answers. All right, now we're going to talk about end behavior of a linear function. And I know this looks a little bit different in your notes, but it's the same thing. Same words, same graphs, just organized slightly different. So if we're talking about a positive linear function, what we are talking about is something that has a positive slope. Okay, so if it's a positive linear function, it has a positive slope. But most importantly, I've got to erase that because that just looks horrible. Really what we're looking at here is, where is this function pointing? Where is this graph pointing? Well, it's pointing up, so it's positive, okay? We can also describe that with our words using as the value of x is increasing. So as my value of x increases, what is happening to my value of y? Well, that's also increasing. So as one goes up, the other goes up. If I also looked at it decreasing, if the value of x was decreasing, the y is also decreasing. So these have the same behavior. As one goes up, the other one goes up. As one goes down, the other goes down. Now, a negative linear is when you have the value of x is increasing, or here I'm going to point out, note that it's pointing down to our negative quadrant, okay? But as our value of x is increasing, so as these values are increasing, what is happening to our y values? Well, our y values are decreasing. So this has opposite behaviors. If you say, for example, you were looking at a table, if your x values were going up and your y values were going down or getting smaller, then you would have opposite behavior, or you would have a negative linear function. Okay, I know that some people struggle with that. All you have to do is practice, or you can look at, is it positive, or is it ending here in this positive region, or is it ending down below, down here in this negative region? Okay, so that's end behavior. Last but not least, we have positive and negative regions of a function. So the positive region of the function, what it's talking about is the y values. Oops, that's not that. So we're talking about our y values, or our outputs of the function. That's what it means by positive or negative. So our positive region is when the function is above the x-axis, and our negative region is when it's below the x-axis. So where is this function f of x positive? Well, where is it positive? It's positive just in that peak. So how can we explain that? Well, the value of that point is -5. The value of the other point is 1. So that means our x value, our values for x would have to fall between -5 and 1 if we wanted to have that positive portion or positive region of the function. Now, the negative part of the function, or the negative region of function, could then be listed as when x is greater than, and I'm going to write that in, x is greater than, so here, when my x values are below, or sorry, less than -5, that's when I'm down here in the negative region of my coordinate plane. And when x is greater than 1, so over here, then that's when my x values are also in the negative region of my coordinate plane. Okay. If the y values are on the x-axis, they are neither positive nor negative. Now, finally, let's look at some practice. Okay, so here we have three functions, three graphed functions. Function blank is positive when x is greater than 0, while there's only one function that's in that region, so that would be h of x. Function blank is increasing when x is less than 0. X is less than 0 here, and this is the only function that is increasing in both x values and y values at the same time. So that is our f of x function, f of x. And then finally, it asks what function has a y-intercept of 0, -3. Well, that is a y-intercept of -3. So that is our g of x function. Last but not least, function blank and blank have intercepts at 0, 0.